Assalamualaikum and hi! My name is Arina binti ROSLIN and I'll share an interesting topic which is sundial. Have you ever wondered how will you figure out what time it is if your watch has broken down? Actually, we can measure time by making a sundial. A sundial is a piece of equipment that tells you the time based on the sun's position in the sky. Let's learn about the sundial history. Sundials was the first discovered in ancient Egyptian and Roman civilizations around 1500 before century. The ancient Greeks then made sundials their own. They are the ones developed the science of sundial. The Romans then adopted the Greek sundials, and the first non-Roman sundial is from 293 before century.
The main part of sundial are simple, consisting of a dial plate or face and gnomon, which is the element of the sundial that casts the shadow.
On a simple sundial, there is usually a rod or gnomon that stands vertically upright, which it casts a shadow onto a flat surface marked with lines indicating the hours of the day. The gnomon must point towards the true north. As the sun moves across the sky, the shadow of the gnomon's edge progressively aligns with different hour lines on the plate. Such designs rely on the gnomon that is aligned with the Earth's rotation axis. The equatorial sundial has a dial plate parallel to the Earth's equator. Dial plate that receives a shadow is perpendicular to the gnomon's dial. The shadow from the gnomon falls on the top surface of the dial plate in summer when the sun is high, and on the underside of the dial plate in the winter when the sun is low.
The following is the data I obtained by measuring the angle of the shadow.
At each hour, the shadow of the stick was in a different position. The reason for shadows change in shape and position has to do with the Earth's rotation on its axis. As Earth spins, the sun appears to move across the sky. The shadows for simple sundial at 11 o'clock is shorter. This occurs due to the sun is highest in the sky at noon or midday, and at this point, it casts its shortest shadow because it is most directly above us in the sky. In the morning and later in the afternoon, the sun is more off-center and therefore casts a longer shadow. The segments are all equal to each other. This occurs due to the Earth rotates on its axis through 360 degrees once every 24 hours. Therefore, in a single hour, the Earth rotates through 15 degrees. The angle between first and second trial for both sundial are different because the position of the Earth facing the sun will always move slowly due to the revolution of the Earth towards the sun. After 3 weeks, the declination of the sun change is also due to the movement of the Earth moving in its orbit, resulting in shadow casted at different angle after 3 weeks.
The tilt of the Earth's axis affects the length of the shadows. The Earth is constantly rotating and revolving around the sun, which resulting the change in the angle of the shadows. Our place on Earth is dark because the sun's light is blocked by the magnitude of our planet.